Good day, listeners. My name is Audrey Poulton. Welcome to our first educational program in a series of 5 produced especially for grade 10 mathematics learners. The main aim of these educational programs is to help you to understand the difficult content of this subject matter. Today we're going to talk about the classification of numbers. We'll start with the 2 main groups of numbers, real numbers and non-real numbers. Non-real numbers are also called imaginary numbers. Then we'll move on to rational and irrational numbers. You'll hear various examples during the following conversation. So have a pen, paper, and a calculator ready to make notes and work out the examples on your own.
Hi Susie, what's up?
Hey Annie, I'm so excited. My aunt is coming to visit.
Why does that excite you so much?
My aunt used to be a mathematics teacher, and I've been dying to ask her a few things.
How come? You're not bad at maths.
No, but there's this one topic I'm a bit embarrassed to ask our teacher about. You know, when you're one of the top students and you ask questions about the easy topics, everybody laughs at you.
Why would you feel embarrassed? You know that Miss Shimi always tells us that no question is a stupid question?
Yeah, I know, but I still feel embarrassed.
So, what's the topic that you want to ask your aunt about?
Don't laugh. It's about numbers.
Numbers? Are you serious?
Yes, that's why I said it's a bit embarrassing for me.
So when will your aunt be here?
She's arriving tonight. Aunt Mary, you're here.
Hello, my angel. How are you?
I'm good. How are you?
Fine, thanks. So tell me, how are you doing in mathematics?
I'm doing fine, but there are a few things I'd like you to help me with.
No problem, my girl. Why don't you fix me a cup of tea while I put my things in the room?
Sure, Aunt Mary.
Okay, so how can I help you?
Aunt Mary, I've got a problem with the topic of numbers in general. Our teacher talks about real numbers and non-real numbers, and all of a sudden she talks about rational and irrational numbers. It's also confusing to me because I really don't know the difference between them. Can you help me to understand them better, please?
Sure, I can help. Let's start right at the beginning. All numbers are divided into 2 main groups, which are the real and non-real numbers. Now in school, we work mostly with real numbers, but you must be able to identify non-real numbers as well.
So, what is a non-real number?
Non-real numbers are also called imaginary numbers. As the name says, they do not exist and they cannot be placed anywhere on the number line. An example is the square root of a negative number, like the square root of -5. Sometimes we come across answers like that in our calculations.
So, what will happen if I try to calculate a number like the square root of -5?
Why don't you try it on your calculator and see what happens?
Okay, I want to find the square root of -5. Let's see. When I press the equal sign, it says math error. Now what?
Exactly as I told you. That's the calculator's way of telling you there is a problem. Those numbers do not exist on the number line. But like I said, For now, you only have to be able to recognize a non-real number. You don't have to do any calculations. Just be careful though. It's possible to find the cube root of a negative number, because a minus times a minus times a minus will give you a negative answer. It's only the positive roots that can't be negative, such as the square root, fourth root, sixth root, etc. etc. The cube root, fifth root and seventh root can give you either a negative answer or a positive answer.
Thanks, Auntie. That makes a lot more sense to me now. So real numbers are on the number line and non-real numbers are not. That's not so difficult to understand. Another problem I have is that I'm not always sure when a number is a rational number and when it's an irrational number.
Okay, let's look at the meaning of those two words first. Let's start with irrational, because rational is just the opposite of irrational. What does it mean when you say somebody is irrational?
It's when someone is not thinking in a logical or predictable way.
Exactly. That's how you should think about the irrational numbers. They are not logical, or we can say they are not predictable.
So you mean irrational numbers are numbers that behave strangely?
That's exactly what I mean. Try one on your calculator. Find the square root of 8. When you find the value of the square root of 8, you get a very long decimal number.
Let's see. Square root 8 equals, I get 2.828427,125.
And what digit comes after that last 5?
I don't know. There doesn't seem to be a pattern, and my calculator display stops there.
Exactly. The answer is an infinite, non-recurring decimal. That's what we call an irrational number.
What do you mean by an infinite, non-recurring decimal?
Non-recurring means that the digits or groups of a digits do not repeat themselves. An example of a recurring number is 0.33333 and so on. There is no end. It goes on forever, but it repeats and is predictable. A number that doesn't end is called an infinite decimal. Even though it looks like it ends on the calculator, the number still carries on and on and on.
What do you mean it looks like the end?
I use the example of the square root of 8. Read the full calculator display to me, please.
2.828427,125.
On the calculator, 5 is the last digit, but in actual fact, the numbers still continue. If you use a very large calculator, you will see that the number goes on forever. It is infinite.
Oh, I see. And the number is also non-recurring because none of the digits repeat. This number does behave strangely. So that's what irrational means.
Yes, that's correct. Let's look at another example. The number pi, which we use to calculate the area and circumference of a circle, is another example of an irrational number.
You mean 3.142?
No, I mean pi. 3.142 is the terminating decimal fraction which we use to represent pi, but it has been rounded off.
I'm not sure that I follow you.
When you must classify numbers, you have to judge the number that you see. That's why we can define irrational numbers as the square root of non-perfect squares or the cube root of non-perfect cubes.
Okay, so if I find the calculator value of pi, it will give me a very long decimal number. Let me try.
Yes, the numbers on your calculator will be 3.141592654. But 4 is not the last digit. It still continues far beyond what you can see.
What about rational numbers? How do I recognize them?
Rational numbers are the opposite of irrational numbers. And rational numbers are the numbers that we use mostly in everyday life. The short definition is that if you can write the number as a fraction, a over b, where a and b are both integers and b is not equal to 0, then the number is a rational number. Rational numbers can be written as a ratio or as a division of two whole numbers.
So, an example of a rational number is 3.14 or 2 over 5 or 9 over 4.
That's correct. But now I need a second cup of tea because my throat is very dry. I'm not used to teaching anymore. Would you make me another cup, please, my darling?
Sure, Aunt Mary.
I hope you enjoyed listening to the conversation between Susie and Aunt Mary. Because this topic isn't so hard, we tend to spend more time on the difficult topics. Let's go through some examples again. Numbers are divided into two main groups, namely real and non-real numbers, or imaginary numbers. Non-real numbers are those numbers that don't exist on our number line, and you don't have to use those numbers in your calculations. You only have to be able to identify them as non-real numbers. An example of a non-real number is the square root of a negative number. For example, the square root of -5. If you try to calculate these numbers on a calculator, it will give you a math error. Real numbers, however, can be divided into two main groups of numbers. These groups are the rational numbers and the irrational numbers. We can start with the irrational numbers and think of it this way. When somebody is irrational, his or her behavior is unpredictable and illogical. So numbers that are not predictable are numbers like the square root of 3, the cube root of 9 or pi. These numbers are infinite, non-recurring decimal fractions. Rational numbers are numbers that are logical and predictable, and we mostly use rational numbers in everyday life. These numbers can be written as a fraction, a over b, where a and b are both integers, and b is not equal to 0. Examples of rational numbers are 6, 2 over 5, 3.4, and so on. Well, listeners, that concludes our program today. Thanks for joining us, and I hope you will tune in next time. From me, Audrey Poulton, goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.